So how do they get here? Well, New Jersey, we have 3 ports, we have 2 international airports, we have several domestic airports. All this is coming in on solid wood packing material. You think about it, crating. I mean, it's been going on forever and ever. And when it first came in, you don't think about like marble coming in. I know right around here there's some marble industries. That's heavy wood that those things are coming in. Dumbbells are what brought ALB in here. So when you're looking at how this stuff gets moved around is human-mediated transportation. You have international trade and commerce. Everybody sees it. You see all those containers moving all around New Jersey. But the things you don't think about are firewood. Okay, the cargo is pretty simple. Pallets, containers, inside the containers, even though that they may be packed with boxes, things get in. They leave those containers open in foreign ports. I mean, it's one of the big problems for like Guam and other countries is you don't think about it, but things like to crawl into those containers. Nursery stock. We actually gave EAB back to China because they bought a whole bunch for the Olympics. Isn't that crazy? But we did. Raw materials. We found a velvet longhorn beetle in Camden on magnesium, in big boxes of magnesium. You just don't believe all the different things that come in. Stone products, like I mentioned, marble, and the cast iron, all our sewer grates and things like that. All that heavy material comes in thick boxes. What I like to point out here is the dispersal, because this is normal flight dispersal, and this you can tackle. You know where they're going to be. You can see the higher density. These are higher populations here, and this is the leading edge. Well, that's not what happens in real life. This is right here. This is Ohio, and this is where Michigan, where they first found it, and this is movement of firewood. It kind of brings hot spots everywhere. So we don't know where the leading edge is, and this goes for all this transportation, whether it's cargo or firewood, and creating multiple satellite locations. The leading edge just goes everywhere. That's how it's spread so quickly. So when you're looking at EAB infestations right now, it's in 30 states, which just a couple weeks ago is only in 28. So we have 30 states now, and then 2 provinces in Canada. And this is within 14 to 16 years. This is our ash distribution, and this kind of gives you the idea of the impact nationally. You have 7.5 billion trees, ash trees nationally. You look at where it is, okay, our ash trees, and you get a little bit over here and a little bit there. And if we go back, look where the EAB is. I mean, at one point, they're really just going to run out of ash unless they get into the West Coast. But they have a good chunk of the United States to go after. One thing I would like to mention: states like up in here, Vermont, Maine, South Carolina, Louisiana, they just haven't found it. So I would easily, say we are on 34 states, or it's one of those things, they're so hard to see. So one of the things for New Jersey, and a lot of this is going to be about New Jersey, is we have 8 confirmed counties. 1 unconfirmed county, and the only reason it was unconfirmed is we couldn't find life stages, and that's one of the things we need to do for new counties. And with that, okay, we can see evidence. We're 99.9% sure, but we need it for our federal documentation. We have 32 municipalities, and if you see where it's kind of, it's spread out in here, we get a little bit up here. Over here is where they found it in New York, West Point. Along here is where Pennsylvania's had it. Do we know where it came from? No. I mean, could it have blown in from Pennsylvania? Could it come in from New York? Could it just come in from our ports? We do not know. But what we do know is we have a higher concentration here. We look, we put traps all in this area to determine it. We would like to know where the leading edge. This is where we do encourage your help, and I'll talk about that in a little bit. So for New Jersey ash distribution, we have 24 million trees and forested. This is coming from New Jersey Forestry, but they said that's double for public and then private trees. So you're looking at 48 to 50 million trees in the state. And unfortunately, it used to be 99% mortality. Now it's around 99.7% mortality from the emerald ash borer if not treated. So we do have green, white, black, and a very rare pumpkin ash. I have yet to see one. And one of the things people go, well, why do we have so much ash? And when I was doing some gypsy moth survey in Manchester, in the Pine Barrens, all those adult communities had lots of ash because they were cheap trees. They grew anywhere in any soil condition. So through the 70s, 80s, and 90s, they were that go-to tree for new communities. So just to give you an idea of the host for this insect, we have two definite, and the third one is because of, it did have a complete life cycle. So you have ash, which again is going to be your your green, white, blue, pumpkin, and black. Okay, your white fringe tree, ornamental tree. It's one that you will see planted in landscapes. It's not a very common tree. We do have some native populations down in Cumberland County, and then olive trees were the new one that kind of threw things like but then everyone's like, well, maybe it's going to go after Russian olive, but we don't think so. But it did have a complete life cycle in olive tree. So emerald ash borer was native to Asia, China, Korea, Japan, and Mongolia. First detected in Michigan in 2002. They believe it was original infestation around 1994. There's a plus and minus on that, but that's the best estimate. So by the time they found it, even if it was 1994, okay, you're looking at 8 years, and when you look at our graphs, that's kind of in that 8 years is when you're going to really notice them. Currently, right now, it's in Somerset, Hudson, and that's our county that I put it on there is the one that wasn't determined, definitively. Hunterdon, Burlington, Essex, Monmouth, Bergen, Mercer, and Middlesex. I told you 29 other states, and then 2 Canadian provinces. So just within the last week or so, we probably have about 3 to 5 additional communities that look positive for this year, and I expect that to increase. So we're going to start with the larva. One of the things to notice, it's about a ½ inch. Actually, Jeff brought some nice live ones. So you have kind of these little points on there called urogomphia on the tail. They have these bell-shaped segments and kind of indistinct head. I'll go over more of the larvae in a minute. But you have 4 larval instars or life stages. They feed only on the cambium layer. The eggs, which are very small and reddish right here, can be laid singularly or in groups. And they create these S-shaped galleries or serpentine galleries. And here's your 4 instars. So one of the things is, how does it kill the tree? And we're going to go back to early biology. Here's this cambium layer in the tree. This is the bark, the dead tissue. This is also your heartwood. But this right here is all your live tissue. And you have your xylem and your phloem. So as water is going up and minerals are going up, the sugars are coming down. So this is that nice sweet spot for these to feed because they're getting all the nice sugars and the carbohydrates from the tree. And think of these as hoses. If I have a 100-foot hose and I cut it at 10 feet, water's only going to go to 10 feet, that 90 other feet. And the same thing what happens with this feeding. If this is the base of the tree and they start going across these and cutting these, water only goes up as far as that damage. So that's how it actually girdles the tree because it's cutting all the uptake of nutrients and water. And as well as the sugars and other things going down. This is kind of critical because they go, oh, it's a little bit of feeding, but when you see that I have some stuff over there to take a look at, this is, you'll see it up in the first part of the canopy, and that's where they start. And as the tree gets more infested, they start going further and further down. And that's why I'll show you the upper signs of the infestation. So we do have a clear-winged borer, which is the bottom one, and just a comparison. You have an indistinct head. You have these 10 bell-shaped segments here. This is Urogomphie, which is right at the end. They look like kind of little pinchers compared to this clear-winged borer, which is actually a moth that you'll find in ash. You have that clear head capsule. You have the prolegs, and then you have the additional crotchets or on the abdomen right here, which are kind of work like legs. You will not find any of that on the EAB larvae because this again is a caterpillar. This is a beetle grub. So with the adult, they're about 1/2 inch long and 1/8 inch wide. That 1/8 inch will also determine that size of that hole. One generation here in New Jersey, however, that can change in new infestations. It can take up to 2 years for a brand new infestation. So if it's in a new area, it may take a little longer or colder climates. Females lay 30 to 60 eggs. So does anybody remember those old Wella Balsam commercials where they tell 2 friends and so on and so on? This is the same thing. This is how things reproduce rapidly. So adults are active between May and August. And I tell you this, and that's based on growing degree days. It can be, we're kind of warm right now, so it may push that a little bit earlier, and when it was colder, it pushed that a little bit later. So this is our target window, and this is what's critical because of either removing trees, treating trees, and knowing when these things for trapping, okay? So adults feed on the foliage up at top. That's what they do. They have this nice little microclimate up there. It's basically feeding on leaves and mating. And then you have a distinctive D-shaped hole, which is this right here. And what that is, all flat-headed borers. So you have a bronze birch borer and then a 2-line chestnut borer, which are in the same Agrillis family. They make D-shaped holes as well. So if you see those in those trees, that's because it is a flat-headed borer, and as it's feeding, it's kind of going back and forth, and it fits out of there nice and neatly. They are metallic green, but there is some color variation. One of the big things, see this nice coppery red on the abdomen here? Once you spread those wings, if you find anything, this is a telltale sign. Nothing else that we have, no other beetle in the United States has this coppery red abdomen. So if you find anything and you want to do a quick diagnostic, that's it. I mean, I can have them all gummed up with bird tanglefoot and just open them up and look at that and know right there. So I don't have to go through anything else. And the infestations go about 1 mile per year, but they can fly up to 10 miles per flight. So they're strong flyers. So can anybody point out which one is the EAB? 5, 3, 2. They're all EAB. Good job. So there is some size differentials. You're going to see bigger males, smaller females, and vice versa, as well as the colors. You can go from that green to a bluish green to even more like a cobalty blue to a purpley red. I mean, you'll see right here, you have the green up at top with the bluish elytra. Then you have entirely blue. This really isn't the best. And then you get more of the red and this coppery red. So there is some color variation in these. So it's not always perfectly green. But you open those wings up, you will always see that coppery red abdomen. So, you know, just because it may not look like it, it could still be it. So the damage. These are classic signs of damage. I mean, we see it here in New Jersey as well as elsewhere. This is that perfect D-shaped hole. That is 1/8 of an inch. They are difficult to see. Unless they're, you know, up 8 feet or lower, they are not easy to see, especially with bark cracks and all that. Plus, we have additional insects that feed that make round holes that kind of look like it. So this bark crack is one of the things. Underneath here is this, all this serpentine galleries. So as that's feeding, all this bark is dead, and as the bark grows that year, it creates a crack. And with that crack, you're going to notice that. And then these are the serpentine galleries. This is this meandering feeding, and it goes from very small in that first instar, and then the wider stuff is that fourth instar until it kind of makes that, pops out, the following year. This is what kills the tree. This is that whole damage I told you. Think about all these as, because all those xylem and phloem are going up and down. You're just cutting those hoses at all different lengths, so nothing is going up. So crown dieback is one of our things. Like I told you, that they like to be up top. It creates a nice little micro habit. Feeding damage always begins in that upper canopy. One of the things that we use as a tool is 30% loss on that canopy. There's really no saving that tree. Pam will show you a nice chart that illustrates that. Tree mortality is in 1 to 6 years, depending on size and vigor. You can get up to 8. Again, it's going to show you a nice graph with that. But 99%, this was the old thing. There's between 99 to 99.7%. We used to have a 1% lingering tree, white ash, and that ash had some kind of chemical in it, whether it be an allelopathic chemical that would be attacked, but it wouldn't be dead. So they're still doing research on it, and it's still white ash, but it's gone down a little bit. So you're going to see this is what's caused by that larval feeding. Again, all these galleries kill it. This was girdled, so you get all these sucker growth or epicormic growth down here. Same here. I told you they start up in the top of the canopy of the tree. All that is dying back because of feeding. So the tree, to try to survive, pushes out leaves in the middle. And that's, again, the tree wants to live until those beetles go further down, and then the tree will eventually die. So one of the things that we do is we monitor, and we have 2 different types of traps. One of the traps is this green lingering funnel, which is my favorite. And then we have these purple sticky traps, which you may have seen. So both of them use a pheromone lure and we used to use a volatile, a chemical that mimicked a sex pheromone. It's what the tree produces when it's being attacked, and use them together. Now we're just using it's called hexanol. And this is somewhat an indiscriminate one because we get lots of additional things. So if any of you ever use one of these traps or work with us, get lots of false click beetles, and pretty much anything under the sun that happen to hit that trap. Whereas these are a little bit more work as far as you check them every 2 weeks, and there's a liquid in the bottom. It's actually RV antifreeze, so when they fall in there, they die quickly. And but they're easier because I got to get all this bird tanglefoot and everything off of there to look at them. So our trapping program is important because I told you we need to know where that leading edge is, and it's helping the communities make decisions. Without that, we're kind of blind. So in 2008 to 2016, we put out 1,900 traps, and actually probably closer to 2,000 when you put some of the lingering funnel traps that we've been using as well on our own. So with that, it's been New Jersey Department of Agriculture, Forestry, it's USDA, APHIS, PPQ, then we have the county tree commissions, and then public works. Some of the public works have helped out, and then volunteers. We appreciate all the help we can get. 2014, we had 4 locations. 2015, 9, so an additional 9. So then we went 2016, we had 19. Does anyone see a trend there? We're going upwards, and it's almost doubling each year. So I can't say this is definitely the trend, but it also goes kind of concurrent with some of the modeling from Cliff Sadoff, but he doesn't do locations. We just thought this was an interesting, thing that was going on here. But 2017, we're not sure. I mean, right now, I told you, we probably have close to 5 locations, and within the last 2 weeks that people have been getting back to me. And I saw pictures, and they look pretty good as far as positive. So our trapping program, 2015 and 16, we used shade tree volunteers and other volunteers. And it was one of those things that the USDA had given us the money or given us the supplies, because we had no money to hire anyone. We had asked people to help out if they wanted to see what was in their community and monitor their community. So we had done a radius of 12 miles outside of known infestations. We went out there and then had other people said, hey, do you mind? We're a little bit out. And we're like, sure, as long as we have the material, you're more than welcome. We have an additional 100 locations this year, so if we do have anybody that's interested, please let me know. Our other tool, and I got to preface, all the things that we're going to be talking about are tools in the toolbox or ammunition. There's not one single magic bullet we have. So everything in here is either used in conjunction with each other or anything. It's not like, you know, you have an ant problem and you can just spray it and it's done. We have multiple things. Some things take a little bit longer. Other things, you know, are a little bit more immediate. But there's not one thing that's going to get rid of EAB. It's going to be doing multiple management schemes. So our biocontrol that we're working with the USDA on, I think is going to be important in the long run. This is not, you got to remember population. So if you have EAB here and we're introducing, biocontrol, these little parasitoid wasps here, their population has to rise. As this is rising, they're rising, and then you're going to get kind of a homeostasis at point, and then we're going to knock the populations down. What we've been doing are releases. We have 4 non-native species. We have Obius agrilli, which is an egg parasitoid. We have Tetrastychus, which is going to be a larval parasitoid. And remember, this works just like, if everybody remembers the movie Aliens, they inject the eggs inside either the egg or the larva. Their larvae eat up the thing and kind of burst out. The same concept. Pretty much most of the biocontrol works like that. So the big thing here is this. See how it's under 10-inch DBH? That's diameter breast height. So smaller trees, they work with smaller trees. So these 2 Spathius we're working on is over the 10-inch. However, the Spathius agrilli is on this 40th latitude. It doesn't overwinter well. So we're working with USDA now to do some survey work to see what we're finding in overwintering larvae and kind of come up with maybe where New Jersey that line is. Because out in Detroit and other places they know. Here we have really weird climate zones. It's not as straightforward. So it's one of these things we have been releasing. There's 5 possible twid wasps, some hemipteran that are like assassin bugs and stink bugs that go after these as well. So in our biocontrol this year, or the past 2 years, 15, we did the fall 15 and then all 16, which was basically a 1-year cycle. We did Hillsborough, Duke, Island Park. Bridgewater is one of the a county park there. Ewing, we did our bug lab right by our bug lab in Ewing. And then in Franklin was the DNR Canal. So in that we released this Obius agrilli and Tetrastychus. Altogether it was 16,800 release for Obius, 31,000, almost 32,000 for Tetrastychus, 48,731 in total. So that's a lot of little bugs to release. So this year our plan is I get to put out yellow sticky cards and see if we're going to trap any of these small wasps to see if they've established or not. Right now we're looking at several townships, 5 in total, to do some new releases. We have Montclair, and then Princeton Borough, we have Rancocas. So we do have 5 locations. We have these whole parameters that we need to release. So everybody goes, well, you can do it in my backyard. Well, we really can't because there's parameters set by USDA and Forest Service. So it has to be detected. You can't release something if there's no food for these guys. So that's one of the first things. You have to know you have EAB. Next one, which is the 40 plus acres of area of forest. Now you have to have 25% ash trees. So again, it kind of makes things harder and harder for us to find. Relatively healthy trees and not slated for any type of development. So these are our parameters that we work with. We are trying to make sure they work with our communities as well. So let's say one township has a park and the other one in their, they're contiguous. We can say, well, we can put them in both communities. Or we have it's not a swath that's maybe a mile wide, but 20 miles long along a roadway. We're looking at other ways to skin this cat that we can release these and still be within these parameters. So that's one of our difficulties right now. So as we said, Jeff brought some. We do take this seriously. I will tell you they taste like Honey Nut Cheerios. He has 3 if you want to try them out. Exactly like Honey Nut Cheerios. We tried this biomonitoring in New Jersey, okay, with a ground wasp, and this one works really well. It's Cercis fumipennis, and what they do is they capture the insect, they bring them down into their burrow. You usually see them in baseball fields, and they lay their eggs or multiple eggs, and they pack up their thing. And someone had the brilliant idea in the University of Guelph, just put a little collar over this thing so the female can get in, but she can't carry anything. So what you do, so what you're going to do is you look right around here to see if she's got any EAB. So it's a nice way of having nature look for us. We did it 2 seasons in New Jersey. I think we manicure our ball fields maybe way too much because we didn't have much success. Connecticut did well with this. We did not. And we went to, I don't even know, like 150 plus locations. So we really, tried to make this happen. And the other thing that we used to look at more as a biomonitoring thing, but now after a lecture I went to early this year, this is also a little bit of a control. So woodpeckers are a great way to tell because they do this thing, it's called blonding or scaling. And think about it, they don't have to go deep in that tree to get the grub, right? They just need to go right underneath the bark. So they're hitting it on an angle. What you're seeing, what I think is evolution going pretty quickly, is seeing they're changing their feeding behavior in response to this. They're also getting larger clutches of eggs in New York, going from like 3 up to 9 for woodpeckers. Again, it's that whole, thing where woodpeckers, their populations go up and EAB as well. But research has shown that the predation of the larvae is up to 50% in some areas. So it's a good thing, but again, we're also worried about when EAB crashes, you have lots of woodpeckers. So I would like to mention a little bit of the EAB resistant trees and some of the research being done, because when you look at it, what are we going to do with trees? How are we going to replace them? Are we going to replace ash trees? So one of the things are gene markers for resistance. It's North American versus Asian. That's a Manchurian ash. Manchurian ash is resistant, so they're trying to crossbreed the two. So we have, but again, these are long-term. This isn't one of those, another magic bullet. It's going to be a while before all this comes to market. And then I mentioned that natural resistance, that lingering tree, that 1%. So they're still trying to determine which chemicals are in those white ash that they are going to use and then hopefully replicate. And then we're also developing transgenic, which are putting Bt into the tree. Again, a bit of a GMO, but if it saves your ash trees in the future, and it will also prevent a lot of other borers, unless they become resistant to that. So other ash pests that you got to realize that there's more things than EAB eating our trees out there. And we do have a number of insects. So we have diseases as well as insects. One of the biggest things I see that are killing ash trees in New Jersey is ash yellows. We also have ash dieback, anthracnose, and then some insects. I'll quickly go over ash yellows. Okay, is by a mycoplasmid-like organism. It's vectored through leaf hoppers or tree hoppers. It gets in there and breaks the cellular wall in the xylem and phloem. So basically, it's like trying to use a 2-horse pump to get water to the top of a 30, 40-foot building. It's just not going to happen. So these basically dehydrate and die fairly quickly. And there's not a lot of research on this at all. I mean, it's very common, especially up in North Jersey. So we have ash dieback, which actually came from Europe. It's a fungus. I've seen some as far south as in Howell. Once in a while, not as much as ash yellows, but I will see it. You'll see these black necrotic areas in the trees, and the rest of the tree is healthy. One of the things I didn't put on here is ash anthracnose, and we saw a lot of damage last year, especially by me, because we had salt damage from Sandy, and then this 2 cold springs, kind of wet cold springs. So anthracnose came in, and between the salt damage and then with the climate, we had a lot of anthracnose. And so we do have other things that make the trees look, not so healthy. So insects, we have a red-headed ash borer right up the top here, and then this banded ash borer. Both of them make about a 1/4 inch plus round to oval holes. This little guy is a bark beetle, and tiny little holes. And these two are moths. Again, they make about a 1/4 inch, a little over a 1/4 inch round oval holes. So these are common insects you will see in ash that are native to here. And sometimes they will kill the tree. They like to go after trees that are in decline and only help them, progress. Sometimes you'll see, for these guys, you'll see the shell casings of the pupal casings coming out, and they look like little thorns. We do have some things that look like EAB. These two up top are in the same family, Gryllus, and you have the bronze birch borer, and then the 2-line chestnut borer. Okay, they go in oak, mostly oak. They used to go in chestnut, but we don't have that much anymore. And this is, as it says, birch borer. It only goes into birch, but it will make that perfect D-shaped hole. This is a ground beetle. It's a 6-spotted tiger beetle. You'll see them in nice sunny spots and trails. This guy is massive. It's a caterpillar hunter. It was brought in for gypsy moth in the 1950s, I think. And if you touch it, it gives like rotten cheese smell, so I don't suggest it. This is just a flower beetle you'll see in the summertime, a big June bug. So one of the things that I got involved with a couple years ago is to think, okay, very small bug, but it has a huge impact. And no one goes, what's your impact? So it kills some trees. People are like, okay, it kills some trees. But you don't look at what really the broader picture. So I'm looking at the cascading impact of not only EAB, but hemlock woolly delgid, and then pretty much any other invasive. So biodiversity, you're going to lose, once you lose those trees, there's anywhere from 29 to 52 monophagus, which means it only eats ash species of moth. So you can create a little extinction of that moth in North America, but then you ask yourself, what eats the moth? Tree frogs, whatever, and again, this moth may be what they call a keystone species, which means it's the only thing that eats it. So when you have these huge changes in food webs and system dynamics, the trees die, so now you have other things such as, nitrate leaching into water. So now you have eutrophication in lakes because, so it's not just a little bug killing some trees, there's a bigger, consequences to all that. You look at the system dynamics, habitat loss. So, okay, all the trees die. Where do you think the bears go? They go into somebody else's yard. So, it's all these animals that are displaced as well. Environmental, the trees go. So what happens to all your stormwater? You have to look at those environmental services. And then your soil, erosion, and then your air quality. Economics, it's, that's one of our, I think I spend way too much time on it, is the cost of eradication, the cost of then bringing stuff in here. What are they putting into the environment as far as, trying to get rid of the stuff in those containers? So there's a whole cost of all that. And then the social. Okay, when I did the Asian longhorn beetle, we removed a lot of trees because we really had to. I explain it, it's easier to remove your pinky finger and save your hand than let it to go on if it was like gangrene or something like that. And we did that, and it was 99.79% effective, what we did for ALB, Asian longhorn beetle, that, that was the right thing to do, but some areas went to look like golf courses because we had to remove those trees. So, there's aesthetics, and then your real estate, values and things like that. So a little bit, some of the scary, I know Pam will touch on this. So it has killed hundreds of millions of trees. I mean, last thing I heard was like 350 million, but that was over a year ago. And, 6 states are now included, 6 more states. So this is an estimate 2019 will be $10 billion. And then another one, a 10-year study, EAB will cause more than $20 billion in landscape trees. Good for landscapers, but not so good for homeowners. And like I told you, EAB is very difficult to detect. And Pam will show you, there's a nice little chart when you can see that.